Kenneth Arrow's Social Choice and Individual Values, published in 1951, stands as a monumental achievement in 20th century economic and political thought. This seminal work, emerging from the fertile ground of post-war mathematical economics, rigorously examined the possibility of aggregating individual preferences into a coherent social preference ordering. Its startling conclusion, now known as Arrow's Impossibility Theorem, demonstrated the inherent difficulties in designing voting mechanisms that simultaneously satisfy a set of seemingly reasonable fairness criteria. The implications of Arrow's theorem reverberate throughout various fields, from political science and welfare economics to games theory and artificial intelligence, challenging conventional wisdom about democracy and collective decision-making. The intellectual genesis of social choice and individual values can be traced to the confluence of several key developments: the rise of mathematical economics during the 1930s and 1940s, spearheaded by figures such as John von Neumann and Oskar Morgenstern, provided the formal tools necessary to analyze social phenomena with unprecedented rigor. Von Neumann and Morgenstern's theory of games and economic behavior, published in 1944, offered a framework for understanding strategic interactions among rational agents, paving the way for a more sophisticated treatment of voting and collective choice. Furthermore, the development of social welfare functions by economists like Abram Bergson provided a conceptual framework for evaluating the desirability of different social states. These developments, alongside a growing interest in the normative foundations of economic policy, set the stage for Arrow's groundbreaking work. Arrow's motivation stemmed from a deep concern with the logical consistency of democratic decision-making. He sought to determine whether it was possible to construct a social welfare function that accurately reflected the preferences of individuals while adhering to certain fundamental principles. To formalize this question, Arrow established a set of axioms that he considered essential for any reasonable social choice mechanism. These axioms included universal domain, stipulating that the social welfare function must be defined for all possible combinations of individual preferences, Pareto efficiency, requiring that, if everyone prefers one alternative to another, then the social welfare function must reflect this preference independent of irrelevant alternatives, asserting that the social ranking of two alternatives should depend only on individual preferences over those two alternatives, and social preferences should remain constant if individuals alter their preferences over other alternatives, and non-dictatorship, precluding any single individual from unilaterally determining the social outcome. The core of Arrow's work lies in his Impossibility Theorem, which demonstrates that no social welfare function can simultaneously satisfy all of these seemingly innocuous axioms when there are at least three alternatives and a finite number of voters. The theorem's proof, employing a sophisticated combination of logic and mathematical reasoning, reveals a fundamental tension between individual liberty and collective rationality. In essence, Arrow showed that any voting rule that respects individual preferences and avoids dictatorship must inevitably violate either Pareto efficiency or independence of irrelevant alternatives. One can view his proof as involving the demonstration that the only social welfare function consistent with the axioms is a dictatorship, thereby showing that it is impossible to have a social welfare function fulfilling all the axioms without having a dictator. The immediate impact of Arrow's theorem was profound and unsettling. It challenged the prevailing belief that democracy could be justified solely on the grounds of its ability to aggregate individual preferences in a consistent and fair manner. The theorem exposed a previously unappreciated logical difficulty in the very foundations of social choice theory, forcing economists and political scientists to reevaluate their assumptions about collective decision-making. Some critics initially questioned the relevance of Arrow's axioms, arguing that they were too restrictive or unrealistic. However, the theorem's robustness and generality, coupled with its elegant proof, ensured its enduring influence. Over the years, Arrow's theorem has been subject to intense scrutiny and numerous attempts at circumvention. One line of research has focused on weakening or modifying the axioms to allow for the existence of social welfare functions that satisfy a subset of the original criteria. For instance, Amartya Sen demonstrated that relaxing the requirement of universal domain by restricting the domain of preferences can lead to the existence of consistent social orderings. Other researchers have explored the implications of using different voting rules, such as approval voting or range voting, which may be less susceptible to Arrow's impossibility result. However, these alternative voting rules often possess their own drawbacks, such as vulnerability to strategic manipulation or Condorcet paradoxes. Arrow's work has also had a significant impact on the development of positive political theory, which seeks to explain political phenomena without making normative judgments. The theorem's emphasis on the strategic incentives of voters and the potential for manipulation has led to a deeper understanding of the dynamics of elections and legislative bargaining. For example, the Gibbard-Satterthwaite theorem, published independently in the 1970s, extended Arrow's impossibility result by showing that any voting rule that is strategy-proof, which means that voters cannot benefit from misrepresenting their preferences, must be dictatorial. These results have highlighted the challenges of designing political institutions that are both fair and efficient. Beyond its direct impact on social choice theory and political science, Arrow's work has also influenced other fields, including welfare economics and artificial intelligence. In welfare economics, the theorem has led to a renewed focus on the limitations of utilitarianism and the importance of considering distributional concerns. The theorem's emphasis on the aggregation of individual preferences has prompted economists to explore alternative approaches to measuring social welfare, such as capability theory and the Human Development Index. In artificial intelligence, Arrow's theorem has inspired research on the design of multi-agent systems and the development of algorithms for aggregating preferences in online environments. The challenge of designing fair and efficient mechanisms for collective decision-making remains a central concern in both economics and computer science. Kenneth Arrow's social choice and individual values drew upon several strands of 20th century thought. First, the concept of Pareto optimality, named after Italian economist Vilfredo Pareto, played a crucial role in formulating the efficiency axiom. Pareto optimality describes a state of resource allocation in which it is impossible to make any one individual better off without making at least one individual worse off. Arrow incorporated this idea into his framework, requiring that any social welfare function must respect Pareto improvements. Second, the work of Condorcet on voting paradoxes provided a historical precedent for Arrow's impossibility result. Condorcet's paradox, discovered in the 18th century, demonstrated that majority rule can lead to cyclical social preferences when no alternative can defeat all others in a pairwise comparison. Arrow's theorem generalized this insight, showing that even more sophisticated voting rules are susceptible to similar inconsistencies. The lasting legacy of social choice and individual values lies in its profound impact on how we think about democracy and collective decision-making. Arrow's theorem has forced us to confront the inherent difficulties in designing institutions that simultaneously respect individual preferences, promote efficiency, and avoid dictatorship. While the theorem dashed hopes for a simple, universally applicable solution to the problem of social choice, it also spurred a wealth of research on alternative approaches and the limitations of various voting rules. Arrow's work serves as a reminder that democracy is a complex and multifaceted phenomenon, requiring careful consideration of the trade-offs between different values and the potential for unintended consequences. The reception of Arrow's work was complex and multifaceted. While the theorem was immediately recognized as a major intellectual achievement, it also faced its share of criticism and skepticism. Some questioned the realism of Arrow's axioms, arguing that they were too abstract or idealized. Others pointed to the limitations of the theorem's scope, noting that it applied only to ordinal preferences and did not consider the intensity of individual preferences. Despite these criticisms, Arrow's theorem has stood the test of time, remaining a central topic of discussion and debate in social choice theory and related fields. The influence of social choice and individual values on subsequent scholarly work is undeniable. Countless researchers have built upon Arrow's framework, exploring alternative axioms, voting rules, and preference aggregation mechanisms. The theorem has inspired a vast literature on topics such as strategic voting, agenda manipulation, and the design of political institutions. Arrow's work has also had a significant impact on the development of game theory, particularly in the study of mechanism. Design seeks to design institutions and rules that incentivize individuals to reveal their private information truthfully, leading to efficient and socially desirable outcomes. Social choice and individual values continues to be relevant in the 21st century, as societies grapple with the challenges of globalization, technological change, and increasing political polarization. The theorem's insights into the difficulties of aggregating diverse preferences are particularly pertinent in a world characterized by deep divisions and conflicting values. As technological advances make it easier to collect and analyze data on individual preferences, Arrow's work serves as a cautionary tale about the potential for manipulation and the importance of safeguarding individual autonomy. The pursuit of fair and efficient mechanisms for collective decision-making remains a central challenge for democracies around the world. In conclusion, Kenneth Arrow's social choice and individual values is a towering achievement that continues to shape our understanding of democracy and collective choice. Its Impossibility Theorem, demonstrating the inherent difficulties in aggregating individual preferences, has had a profound and lasting impact on various fields, from political science and welfare economics to game theory and artificial intelligence. Arrow's work serves as a reminder of the complexities and trade-offs involved in designing political institutions that are both fair and efficient. His legacy lies not only in the theorem itself, but also in the wealth of research and intellectual debate that it has stimulated. Social choice and individual values is a testament to the power of rigorous mathematical analysis to illuminate the fundamental challenges of social life, and a work whose importance will endure for generations to come. The seeming impossibility result offered a stark reminder of the limits to pure mathematical conceptualizations of society.